Hi guys, welcome to Deep Diver. In the last video we discussed Go routine, and in a program we can have as many as Go routine as we want. All those Go routines can execute independently, that's alright, but what if they need to communicate with each other? What if one Go routine wants to send data to other Go routine, and what if a Go routine wants to receive data from other Go routines? How we can do that? So that's where channels comes into the picture, and using a channel you can send data to other goroutines, and you can also receive data from other goroutines. Let us see how we can create a channel and how we can send and receive data over a channel. So this is the VS Code, and I have already created a file channels.go here. So to create a channel we need to use the make function, and here we need to pass what we want to create. So first thing is we'll need to use this chan keyword, which is corresponding to channels, and every channel has a data type associated with it. So let us say we keep the data type as int. This means on this channel we can only send and receive data of type int. Okay. So let us create a variable for this channel. Let us name it ch. Now we will use this created channel to send and receive data. So let us say I create one more function send, and it takes this channel as an input, and it simply what it does, it sends data over this channel. So how does it send the data? So sending data we use this syntax ch left arrow and the value whatever we want to send. Okay, so let me introduce a print statement after and before this sending. So I will write here sending data, and after that I will write sent data. Now let us create a go routine corresponding to this send function. So we create a go routine here for this send function, and we pass the channel. Okay, now in this main function, which is basically a main go routine, we want to receive this data. How we can receive this data? We can receive the data like this: left arrow and then the channel name. So here left arrow is pointing towards the channel, but here the left arrow is coming out from the channel. Okay, so this is for receiving, and this is for sending. So now let us add a string here. So data received over channel, and we'll use the data receive operator here. Okay, and now if we run this code, you can see the output. So if we run this code using go run command, go run channels dot go, you can see it is printing sending data and sent data. That means data was successfully sent, and now data received over channel is 100, right, which is coming from here. Correct. So this is how we can send and receive data over a channel. Now let us look into different types of channels which are provided in Golang. So Golang provides two types of channels. The first one is called unbuffered channel, and second is, I think you already have guessed, this is obviously buffered channel. Okay, so the example we discussed here is of unbuffered channel. So we will discuss this unbuffered channel first in detail, then we will move to this buffered channel. In case of unbuffered channel, there is no buffer to store data. So you can think of this buffer as a queue. Okay. Now let us discuss some scenarios in case of unbuffered channel. So for communication, there are two parties, sender and receiver, right? Let us say a sender is ready to send the data, but the receiver is not ready to receive the data. What will happen? As there is no buffer to store the data, sender cannot proceed further unless it gives the data to the receiver. So unless there is a receiver, the sender will be blocked here. Okay. So sender blocks until receiver is ready. Now let us think of a different case. Receiver is ready to receive the data, but there is no sender to send the data. In that case also, receiver will have to wait until this sender is ready, right? So receiver blocks until sender is ready. To explain it further, let me show these two cases one by one through code. So here we have a send method and this is our main method. In send method we are sending the data, right? Let me comment this send operation. And now let us run this program. So if we do go run channel.go, you will see it is printing an error here. First we have the sending data and send data. As we have commented this got executed successfully, sending data and send data. But now it is reporting a fatal error. All goroutines are asleep. Why? Because of a deadlock. And it is also giving the details about the deadlock. So goroutine 1 is basically the part of deadlock, and this goroutine 1 is basically main.main. So this first main is the package name and this second main is the function name main. And it also giving you here why it failed. The deadlock was on a channel receive. And you can also see the line at which this error came. So the line number is 31 and 31 corresponds to this receive operation here, right? Okay, so this was our second case, receiver blocks until sender is ready. Now let us try to replicate this first case, sender blocks until receiver is ready. So here we will uncomment this, which means sender is ready to send the data, and we will comment this line, which means this go routine is now not ready to receive the data. Now let us run this code. So go run channels.go. What will be the output here? If you have seen the video on go routine, then you might be able to predict the output here. So it will not print anything. Why? Because we are not waiting for this go routine to execute. This main function simply creates a go routine and then it finishes its execution, because of which this send go routine is not getting time to execute. Okay, so to fix this, we'll just introduce a sleep here. So let us introduce a sleep for 10 seconds. Now let us run this code again. So if you see here, sending data has been printed, and now for next 10 seconds it will print nothing. Why? Because sending data got printed and then it reached to this statement, which is basically trying to send data over the channel. But in this main go routine, there is no one to receive this data, right? So the go routine corresponding to this send method is blocking here for entire 10 seconds. And when this main finishes its execution, this send go routine also exits, but it has not executed these two steps. It only completed these steps. Okay. To make it more clear, let us discuss this with a real life example. So let us move to the iPad. So let us discuss the scenario of relay race. So what happens in a relay race? There are multiple participants, but for simplicity we will keep only two. So there will be participant 1 and participant 2. So this first participant will make a lap of the ground. Okay, it will make the first lap and it will pass the baton to the second participant, right? And when this second participant will receive the baton, it can go and finish the last lap, right? You can assume this P1 as it is sending the baton to this P2 as sender, and this P2 as a receiver as it is receiving the baton from P1, right? So let us say the sender has completed the first lap, but receiver is doing something else. So what will happen? This sender will not be able to pass the button and it will be blocked here, right? And for the second case, let us assume this receiver is ready to receive the button, but the P1, which is the sender, is still doing the lap. What will happen? In that case also, this receiver will have to wait, right? So this is identical to the unbuffered channel example, right? So let us discuss that as well. So in our first example, what we did, we first created a channel like this, ch make, then chan keyword and the data type, right? In the first example we discussed where we had a deadlock, what was there? We had the main go routine which was ready to receive the data, right? But the send go routine was not sending the data. So this we had commented it out, right? So what happened in this case? A deadlock was reported. Why? Because this main go routine was blocked here waiting for someone to send the data, right? And in the second case, what happened? We also had a channel there. We created like this, make chan int. There we had the send go routine which was sending the data, but in the main go routine there was no one to receive this data, right? And as here we had a sleep of 10 seconds, what happened? This send go routine was blocked here for 10 seconds, and when this main go routine completed its execution, the send method also completed its execution, but for the entire 10 seconds it was blocked here, right? So I think these unbuffered channels will make much more sense with these examples. Okay, so let us move to the buffered channel. In case of buffered channel, the channel also has a buffer, which basically means a queue. So if this is the channel, then this channel also has a buffer associated with it. Okay, and how do we create this buffered channel? We still use this make function, but along with the first parameter which we were using for unbuffered channel, it has one more parameter which is basically the size of the buffer. So let us say we keep the size of the buffer as 2. So it basically means this channel will now have a queue of size 2. Now let us create a scenario. So there is still the sender here and the receiver. Let us say at time instant t1 the sender wants to send 1, then at time instant t2 the sender wants to send 2, then at time instant t3 the sender wants to send 3 over the channel, and at time instant t4 this receiver wants to receive over the channel, and similarly for time t5 it wants to receive over the channel, and at time t6 as well it wants to receive over the channel. Now let us trace it out what happens in this scenario. So at time stamp t1 the sender wants to send 1 over the channel. Okay, so here in case of buffered channel, sender does not wait for the receiver to be ready. It is dependent only on the queue. So it will check the queue, and if it sees the queue is not full, then it will be able to put the data in the queue. So here queue is empty. So at timestamp t1, the sender will be able to put 1 into the queue. Okay. Similarly, at timestamp t2, the sender will again see there is still a space available in this queue. So it will be able to push 2 into this buffer. So this is done and this is done. Now what happens at time t3? So at time t3 the sender checks the queue is already full, so it is blocked here. So the sender at time t3 will get blocked and wait for the queue to have some space available so that it can put the data into the queue. Okay, For now it is blocked. Now at time t4 this receiver wants to receive the data over the channel. So it will not wait for the sender, but it will directly check the queue. It will check that the queue already has some data. So at the timestamp t4 it will get 1. Okay, so this queue is first in first out, right? So as 1 was pushed before, so this receiver will also receive this 1 first. Now what happens? This sender was blocked here, right? But at times t4 it consumed 1 from the queue, right? So it is no more blocked and it will be able to push 3 here. So this queue is basically a circular queue. Okay, and at timestamp t5 the queue has now 2 and 3, so 1 is not there. So at timestamp t5 it will get 2, and at timestamp t6 it will finally receive 3. What happens if time t7 it again wants to receive? So as this receiver is already consumed 1 to 3, which means the queue is now empty, right? So let me delete the data from the queue. So the queue is now empty, right? So at timestamp t7, if the receiver wants to receive the data over this channel, it will be blocked here as well. So it will be blocked. If later, if the sender is again sending some data, let us say 4, then again it will be unblocked and will receive the data as 4 here. Okay, now let us go to VS Code and do the coding for this buffered channel. Let us first summarize whatever we discussed about buffered channel on iPad. So first thing is, buffered channel obviously has a queue to store data, right? And again there is two parties, sender and receiver, but here sender blocks. When does it block? If the queue is full, right? And receiver blocks if the queue is empty. Now let us first create the buffered channel. To make it buffered, we just need to provide a value in the second argument, which is greater than 0. Let us say we give 2 here. So this means the buffer, which is the queue, is of size 2. Now let us make some more changes, and I will try to show you the blocking behavior of the sender and receiver based on the queue is either full or empty. So I will get rid of this code from this send. So let us run a loop for 5 times, and inside this loop we will try to send I here. Now what we will try to do here, we will try to calculate the time taken while doing this send operation. So here we will be using some functions from the time package. So let me create a variable start, and I will use time dot now here, which basically gives us the instant at which this line of code was executed. And here we'll try to calculate the duration using time dot since, and we'll pass here a start. Okay, and let us add a printf here. So the time taken in sending %d is %v. So this %d is for I, and this %v is for the duration. Now in the main, let us get rid of these 3 lines, and let us say we also have a loop here which runs for 5 times, and now we will try to receive here. Now let us introduce some sleep so that we are able to fill the buffer. So time dot sleep, let us say we sleep for 5 seconds, and inside this loop also, after receiving over the channel, we let us say sleep for 2 seconds. Okay, so what changes we did in the send function? we are having a for loop which is running for 5 times, and here we are trying to send the data over the channel, and here we are also measuring and printing the time taken to send the data over the channel. Okay, and in the main function we again run a loop for 5 times, and here we are just receiving, and between every receive we have a sleep of 2 seconds and an initial sleep of 5 seconds as well. Now let us try to run this code. Let me clear and do go run channels dot go here. So let us do one more thing. Let us add a new line here as well so that output is clear. And now let us run this again. So here you can see time taken in sending 1 is in microsecond. Similarly, for time taken in sending 2 is in again nanosecond. But if you see here, time taken in sending 3 is more than 5 seconds. Why? Because we created the buffer of size 2. Okay, so the first two send here for value I is equal to 1 and I is equal to 2, send happened instantaneously, but for I is equal to 3, as the buffer was already full, right, with 1 and 2, it waited for this receiver to consume the data from this queue. Okay, so once this 5 seconds passed, this receiver was able to receive the data from queue, means there is some space available to push the data. So that's why you see time taken in sending 3 is 5 seconds, and after that every 2 seconds this receiver is consuming the data from the queue, right? So that's why you see for I is equal to 4 and I is equal to 5, time taken in sending 4 and 5 for just more than 2 seconds. Okay, so I hope this makes sense. Now let us try to make sure that this receiver is blocked. And when does this receiver will blocked? When the queue is empty, right? So what we will do, we will cut this from here and paste it here, and we also need this first line. So let us keep that as well, and here instead of sending we'll write receiving. Okay, and in starting here we will do a similar thing. We'll introduce a sleep for 5 seconds, and after every send we'll sleep for 2 seconds. Okay, and in this receive function what we'll do, we'll get rid of this sleep. Okay, get rid of this sleep. Now let us run this program. So we'll do go run channels.go, and you will see the output here after first 5 seconds. Okay, so in send, as we had sleep for 5 seconds, the first receive happens after 5 seconds here, right? Why? Because this main go routine, which is the receiver, was blocked here waiting to have some data in the queue. Once this send puts the data into the queue, it was able to receive that data. And for the rest, from I is equal to 2 to 5, as this sender is putting data every 2 seconds, that's why you see for the rest of the 4, time taken in receiving is little more than 2 seconds. Okay, I hope this makes sense to you. Now let us move forward and let me tell you one important thing. So as this send is doing only the send operation, and this channel is bidirectional, but while passing to this send function we can make this channel unidirectional. Okay, so as this channel is doing send operation, so if we change the syntax like this, then this send function can only send over this channel but cannot receive over it. So if we do something like this, it will give compilation error. What is the error here? Invalid operation cannot receive from send only channel. Similarly, if we had some other function like this function, let us say receive, where as parameter we have the channel, And if you want to make sure that this receive function only does the receive operation over this channel, you can change the syntax like this, and if we try to do send operation, it will give a compilation error. So you can see here invalid operation cannot send to receive only channel. So we do this in order to avoid mistakes. Okay. Now let us go to iPad and summarize the differences between these two types of channels. Now let us summarize the difference between unbuffered and buffered channel. So this column is for unbuffered and this is for buffered. So the first feature is capacity. As we already know, this unbuffered channel does not have any buffer or queue associated with it. So that's why the capacity here is 0. But this buffered channel has capacity more than 0. And the next feature is synchronization. Unbuffered channel provides us a strict coordination. Why? Because the sender will not be able to send until the receiver is ready, and receiver will not be able to receive until the sender is ready, right? So that provides a strict synchronization between sender and receiver. So as in case of buffered channel, the blocking of sender and receiver depends on the queue. That's why here the synchronization is loose. Okay. So in case of unbuffered channel, send blocks until the receiver is ready, and in case of buffered channel, send blocks only when the queue is full. Similarly for receiver, in case of unbuffered, the receiver is blocked until the sender is ready, and in case of buffered, it is blocked when the queue is empty. Okay. The common use case of the unbuffered channel is coordination, and going forward we will see some example of this in next videos. And in case of buffered channel, it is generally used for work pipeline, like there is a producer, right, and there is a consumer. So producer will keep pushing the data to this queue, and this consumer will keep receiving it. Okay. Going forward in next videos, we will see examples of where do we use unbuffered channel and where do we use buffered channel. That's it for this video. See you in the next one.